So what I want to do with this session is talk about other fields of science and how science confirms biblical creation. We've already touched on astronomy, my specialty field, but there are other fields of science, and they're all interesting. I love them all. And it's useful for us to know a little bit about the basics of various fields of science so that we can talk intelligently with our friends on these topics. And I want to show you that science does confirm biblical creation. It makes sense. Science makes sense in light of biblical creation. We all have a way of looking at the world. We look at it through our worldview. We talked about that last night. Creationists and evolutionists look at the same planet, and we draw very different interpretations about what the evidence means, because the evolutionist, the secularist, is looking at the world in terms of naturalistic thinking. He's thinking in terms of millions of years of gradual evolutionary processes producing life on Earth. And so when he picks up a fossil, he already has that in his mind. And that affects the conclusions that he draws about the fossil. Biblical creationist is thinking in terms of biblical history, creation, the flood, and so on. And when we look at the fossils, we think about that in terms of the way we draw conclusions. And I'm not going to argue today that the biblical way is the right way of looking at it, because we demonstrated that last night. The biblical worldview is what makes science possible. And so to look at the evidence from an evolutionary perspective, you can do it, but it's irrational, because the idea that you're applying science presupposes the biblical creation worldview. That's not what I'm going to do today. What I'm going to do today is talk about some of the evidence and how the evidence makes sense in light of what the Bible teaches. I'm going to cover several different fields of science today, 3 fields, briefly. I'll spend the most time on genetics, because that really is the most relevant, I think, to the creation-evolution controversy. The genetics, the study of how traits are passed on from one organism to the next. We'll talk about information theory, about what information is, how it's transmitted, and so on, and we'll find that that strongly confirms biblical creation. Then we'll talk about geology, along with paleontology, the study of rocks and the study of the fossils that are found in those rock layers. And we're going to find that the evidence makes sense in light of biblical creation. So let's start with genetics, the study of heredity, the study of how traits are passed on from one organism to the next, the study of how animals change. Do animals change? Do dogs change? Do dogs change? Dogs do change. What do they change into? Dogs. Yeah. Dogs change into dogs. And we would expect that, because the Bible indicates that God created animals according to their kinds. God did not make animals to reproduce exact duplicates of themselves, except in the microscopic world. But in terms of sexually reproducing organisms, God has built in variation. We'll see how that works. And so you can get lots of different breeds of dogs today. And that's not evolution. That's just dogs. Dogs giving rise to dogs is not evolution. It's just dogs. We'd expect that. The Bible uses this phrase, after its kind, after their kind, over 10 times in Genesis 1. That's how many. That's God indicating that the kind is apparently the reproductive limit of an organism. So different kinds are not related to each other. They're uniquely created by God. Now, I need to point out that kind does not mean species, and this confuses some people, because a species, that's a man-made classification system, and so it doesn't have to line up exactly with the biblical terminology. But you can get different species that are from a common kind. For example, a group of mosquitoes goes off and lives in a cave for 100 years, and then when it's brought back out, due to genetic drift, it can't interbreed with the parent population. And so it's classified as a new species. But they're still mosquitoes. What were they? Mosquitoes. What will they be? Mosquitoes. That's not evolution. That's just mosquitoes. Right? So, but they're classified as a different species because they no longer normally breed with other mosquitoes. Okay? And so that's how species is defined. Kind is different. Kind is the original reproductive limit of an organism. So this is important because I find that evolutionists often misrepresent what it is that creationists teach. Evolutionists, either due to ignorance or deliberately, hopefully it's just ignorance, but they'll often say that creationists believe that God created all the species as we see them today. Now, I don't believe that. I don't believe that for a moment. Or God, in some versions they'll say, and God created, that creationists believe that God created all the organisms just like they are today, even in their current locations. Well, that's nonsense. That's not what the Bible teaches. I don't believe that there were poodles in the Garden of Eden, right? There's a paradise. You're going to have poodles running around and biting your leg, and that's not going to happen. No. Animals have changed since creation. Yes, we had dogs. at the original creation, just not poodles. This is not what we believe, the idea that animals have remained exactly the same over time. What we believe is, in fact, more like this: variation within a kind. Animals do change. Dogs change quite a bit. They're still dogs, right? And so God did create the dog kind back at creation, and they've branched off into lots of different breeds. And poodles are just one of these horrible examples up here of as a result of the curse, as we'll see in a little bit. But and of course, some kinds have gone extinct. We don't find the kinds of dinosaurs around anymore. There are some kinds where some varieties have gone extinct, but other varieties remain. Elephants, for example. Mammoths are part of the elephant kind. We believe they're generally related. It's just that particular variety is gone. Whereas you have the Asian elephant, the Indian elephant, they're still around today. So variation within a kind would be the biblical teaching, because organisms reproduce according to their kind. Whereas in the evolutionary worldview, there are no kinds, really, because all life is supposed to be descended from a common ancestor over billions of years. And so, as I mentioned previously, if you believe in evolution, you believe you're related to broccoli. That's your distant cousin. So it's cannibalism when you eat broccoli. So the change is unlimited and upward. Bacteria eventually become something like a horse and a person and broccoli and everything. Now, to see which of these views is confirmed by science, we need to know a little bit about DNA. DNA is a long molecule that occurs in the cells of your body. It's broken up into a number of pieces that are chromosomes. But basically, DNA looks something like a twisted ladder, and on the rungs of this ladder are nucleotide base pairs. And there's 4 different types that are found in DNA, and they're abbreviated by the 4 letters that you see there: C, G, A, and T. And they can, if you look at one strand, the letters can occur in any order. You don't know in advance what it's going to be. And that the order of those letters spells out the information to make you. It spells out the amino acid sequences that are necessary to make the proteins that make you. You're made of proteins and other stuff, but mostly proteins. And so it's much like you could spell help with beads on a rope in Morse code. Likewise, you could spell out information in DNA. And it's a very efficient way of encoding information, because if you think about it, all the instructions to make you are encoded in your DNA. Pretty remarkable. And so the reason that you're a person and not a cabbage is because you have the instructions to make a person in your DNA, and a cabbage has the instructions to make a cabbage. And aren't you grateful you got the better deal on that one? And by the way, some of the instructions are the same because we use some of the same proteins. If that weren't the case, then you could not gain nutrients by eating cabbage. So it's important that we have some of this. Some of the DNA is the same. You have some of the same DNA as a banana. And that's good because you use some of the same proteins. So you can eat a banana and you can gain nutrients from it. That's very important. Because people, sometimes the evolutionists will say, well, why is it that we have DNA in common with a banana and a fruit? And the answer is because God knew we would need to eat these things. If God made totally different DNA and totally different proteins, therefore, for everything, then the only thing we'd be able to eat is each other. And that would be a bad idea. So, yeah, we do have some of the same DNA. Now, what's really interesting is you have 2 sets of DNA, and you get some of your DNA from dad, you get some of your DNA from mom. They have 2 sets of DNA, and it's the combination of the 2 sets that determines your traits. And so when mom and dad have kids, then the child gets one of the 2 bits of information from each set of the DNA, and it's random. At least we can't predict which one they're going to get. So they might get, they're just getting one of 2. So you're getting half of the information in your DNA from dad. You're getting half the information from your mom, but you have 2 sets of DNA, and that determines your traits. And that's why you look a little different from your brothers and sisters, but you also look a little bit similar because you have some of the same traits. But because you have a unique combination of DNA, you have unique traits, unless you have an identical twin, and then you have the same DNA. But here's how it works with a blood type, for example. So you have your 2 sets of DNA, and if you have a gene is a section of the DNA that determines a trait. And so if you have the A allele is a possible gene. So if you have A and A, your blood type's A. So if you get A from dad and A from mom, your blood type's A. If you get A from dad and O from mom, your blood type's still A, because A is dominant and O is recessive. A dominant gene kind of covers up a recessive gene. Maybe you remember doing this in school. If you have the 2B, your blood type's B, or B and O, because B is dominant, O is recessive, so your blood type's B. If you have the combination A and B, your blood type's AB, because they both express. And then the only way you can have blood type O is if you have both O alleles, because O is a recessive gene. And so that's how it works with blood type. So there's the 4 blood types that occur in human beings. And there's our age factors and things like that, but that's the basics of it. And the thing I find interesting is how it works in terms of passing on traits. So let's say mom has blood type A, and let's say it's the what they call the heterozygous A. That's where you have A and O. They're mixed. And let's say dad has heterozygous B. So mom has blood type A, dad has blood type B. The children could have any blood type. Interesting. So one child might get the A allele from mom and the O from dad, and so her blood type would be A. Her brother might get B from dad and O from mom. His blood type will be B. The next child might get A from mom, B from dad, blood type will be AB. And the next child might get O from mom and O from dad, blood type will be O. Interesting. And so, one person says, well, I've got the same blood type as mom. The next one says, I got the same blood type as dad. The next one says, was I adopted? No. No, you still got the information from your parents. Right? And the next one said, I don't have blood type the same as my parents. What's going on there? No, you still got the information from your parents. You just have a unique combination, right? And so you might have I have brown eyes like my mom. My brother has kind of hazel eyes like my dad. My sister has blue eyes. And I used to tell her she was adopted, but she didn't know. I was just funning with her. Now, the blue color, it's a recessive gene, and so that is possible. That works out that way. So here it is with skin color. We all have, by the way, we have basically the same skin color. Did you know that? Brown. It's just a question of how much. How much? And so if you have these types of genes up here, you have lots of melanin in your skin. That's a pigment. There's a couple different forms of it, but the main form that we're talking about here is kind of a grayscale. And if you have a lot of it, and it's well distributed in the cells, you're very dark complected. If you have this combination of genes down here, you're very light complected. Now, interesting thing is, if you're in this box down here, and so you have light skin, and you get married to somebody who's in that box who's light skin, your kids are going to have light skin, because that's the only the lowercase letters are available, and so there's no possibility for new combinations. Okay, that's what they call the homozygous combination. You get locked into that. And likewise, if you're up here and you get married to somebody up there, your kids will be there. Likewise, if you're here, you have only uppercase A's and only lowercase B's, and you get married to somebody in that box, your kids will be in that box. But if you're off axis, if you're over here, and of course this has the same skin color as that, but the reason's different. So here you have the heterozygous combination, and you get married to somebody in that box, your kids could have any skin color, ranging from very light to very dark. And so we think Adam and Eve probably had a combination like this. There's other ways to do it, but they were probably middle brown, and because we're all descended from them, all human beings are. And so it might have been very interesting. When they had children, it might be, I wonder what shade this one's going to be. I wonder what shade that one's going to be. It might have been very exciting for them. But and then over the course of time, you get locked into some of the homozygous combinations. So, and by the way, there are places in the world even today where this is still, there's certain places in India where you have this combination, and people will sit down at families will sit down at the same dinner table, very light to very dark shades. And so that's how it works out. That's just skin color. That's just one example. We're going to talk a lot about dogs because there's a lot of variation within the dog kind. The genes for long fur, short fur, and different colors, different color eyes, and so on. Big dogs, little dogs, and so on. Lots of combinations there. But it's all due to the information that God put in the dog kind. The 2 dogs that got off Noah's Ark, all the information was in them to make all the different breeds of dogs that we have today. It's pretty awesome. And we'll see how that works. But here's the thing I want to emphasize. In the evolutionary worldview, you've got something like bacteria, single-celled organisms, billions of years ago that evolved from by chance from chemistry. And then today you've got more complex organisms like a horse. Now, a horse has a lot more information in its DNA. It's got more instructions. It's not just that it has more DNA, which it does, but it has more instructions in its DNA. It has information in its DNA that bacteria lack. A horse has information for how to make bones. Bacteria don't have that, which is why they can't make bones. A horse has information for how to produce legs and feet and eyes and so on. And bacteria don't have those instructions, which is why they can't produce those traits. That makes sense, right? So it seems to me if something like bacteria, evolved into a horse, which is what the evolutionists believe, then at some point, the animal had to gain new information in the DNA. Does that make sense? Because you have some information here, but you don't have the information for eyes and hooves and things like that. So in order to produce a horse, it must have gained those instructions at some point. My point is that evolution absolutely requires brand new information to be added to the DNA, to the genome, in order to work. And that's not the only thing that it requires. There are all kinds of problems with evolution. But at the very least, if you're not gaining new information, then it's not evolution, is it? I mean, if these bacteria were to lose some instructions, they're not going to turn into a horse that way, are they? So that's the main point I want you to take away in this first session, is that evolution requires brand new genetic information to be added. It requires an increase in information. I'm saying that a few different ways to make sure you get it. And that's interesting, because scientifically, you know what we observe scientifically? Decrease in information. The processes that we observe in nature either decrease the information or are neutral, which means they are in the opposite direction to make evolution happen. Isn't that interesting? And I want to give you, first of all, an example of this, of natural selection. A lot of people think natural selection is evolution. It's not. It's the opposite. Natural selection is a true principle of nature. It's a creationist discovery, by the way. Edward Blyth discovered natural selection. Darwin did not. Darwin might have named it, but the principle is opposite of evolution. Because remember, evolution is about increasing information. Natural selection decreases information. Let me show you how it works. Suppose you have two dogs. And suppose that each dog has a gene for short fur and a gene for long fur. And suppose those genes have a combined effect, which many genes do, such that each dog has medium length fur. Okay, it makes sense? Now this is simplified, but the basic genetic principles are true. And suppose those two dogs, they fall in love and they get married. And I do this for kids sometimes. So now when they have offspring, some of the pups are going to get the short gene from mom, the short gene from dad, and they're going to have short fur. Some of the dogs are going to get the short gene from mom, the long gene from dad, or vice versa, the long gene from mom, the short gene from dad. In fact, 50% of the offspring would have that combination statistically, and they're going to have medium length fur just like their parents. Okay? And then some of the dogs, 1/4 of them, will get the long gene from mom, the long gene from dad, and they will have long fur. Okay? Now, already we have a great example of variation within a kind. We had dogs with medium length fur, and we ended up with dogs with varieties of length of fur, short, medium, and long. That's a great example of variation within a kind. But they're still dogs, aren't they? There's no evolution yet. And in fact, there's been no new information gained, because we started with information for short, long, and by combination medium, and we ended up with dogs that had information for short, long, and by combination medium. So there's no evolution yet. There's been no new information. Now let's suppose the environment gets very, very cold. What's going to happen? Well, the dogs that have the shorter and medium length fur, they don't do so well in that cold environment, right? The dog that has the longer fur, he's quite comfortable. He's well insulated against the cold. But the dogs that have the shorter and medium length fur are not so well insulated, and so sadly they die. Very sad. But the dogs that have the longer fur are able to survive because they're well insulated against the cold. Now they meet other dogs that have survived because they're also well insulated against the cold, that have the longer fur, and they reproduce. And what kind of dogs are they going to reproduce? Dogs with longer fur, right? And if you think about it, that's the only combination that's possible now, because these dogs only have information for long. They both have L genes, and so the offspring is going to have long fur. There's no other choice at this point. If the environment got hot, would they go back to having short fur? The answer is no. They just die, because that information has been lost. Now you notice something. This is a great example of adaptation. It's one type of adaptation. The environment got cold, and the dogs that ended up surviving had longer fur. That's pretty neat. Not that they've adjusted themselves, but rather the dogs that didn't already have long fur died in that environment. And so it's a great example of adaptation. But is it evolution? Have we gained any new instructions? We started with information for short, long, and medium, and we ended up with just information for long. Have we gained new information? No, we've lost information, haven't we? We've lost the instructions for the longer or the shorter fur. Now, if we started the experiment over again and we had all three varieties, short, medium, long, and this time we put them in a hot environment, now what's going to happen? Well, now the dogs with the longer fur don't do so well in that environment, and so sadly they die. But the dogs with the shorter length fur, they do well in that warm environment. They're able to dissipate their heat better, and so they meet other dogs that have survived in that warmer environment, and they reproduce, and all the dogs are going to have short fur at that point. And so, I mean, this makes sense, but my point is, natural selection is the exact opposite of evolution, because evolution requires new instructions to be added to the genome. Natural selection results in the loss of information, because the animals that have information for traits that are not conducive to survival in that environment die, and the information is lost with them. So again, we started with information for long, short, and medium, and we ended up with just information for short. We've lost information. Natural selection only reduces information. Think about it. All it's doing is referring to the death of organisms that have information producing traits that's not conducive to survival. And so we find, lo and behold, dogs that end up in the colder environment have the longer fur. If they didn't, they'd die. Dogs that end up in the very hot environments have the shorter, thinner fur. If they didn't, they'd die, and so on and so forth. And so you see, you don't need to take two of each breed of dog on Noah's Ark, right? You just need two dogs. You don't need to take two Dalmatians and two dingoes and two collies, and you certainly don't need two poodles on board Noah's Ark, right? You just need two dogs. And they get off Noah's Ark and they spread out, and they carry certain genes with them. And if those genes, as they spread out, if those genes are conducive to survival in that environment, then they're preserved. If not, they die out. And of course, some genes are kind of neutral with respect to survival, like eye color doesn't really matter too much in terms of survival. It's just which population ended up with that characteristic. That's just genetic drift. And so, lo and behold, dogs that are in colder climates, they do have thicker, longer fur. Dogs that are in hot environments do have thinner fur. This is a great example of adaptation. The dogs have adapted to their environment by virtue of the fact that the dogs that weren't already adjusted have died. It's a great example of natural selection or survival of the fittest. But it's not an example of evolution, because we started with dogs, ended up with dogs. That's not evolution, that's just dogs. And we don't have any new instructions. In fact, we've lost information. We've lost information for those traits that would not be conducive to survival in that environment. So this is how we account for the different kinds of wild dogs that we find in the world. It's the built-in genetic information, along with whether or not that information produces traits that are helpful for survival in that environment. If they're not, then the dogs die out in that environment. So you can account for wild dogs that way. Well, what about mutations then? Because evolutionists will say, but Dr. Lisle, it's not just natural selection. It's natural selection and mutations that drive evolution. So let's talk about mutations. A mutation is a mistake in your DNA. Think of it as a typo in your DNA. And believe it or not, you actually have in your DNA mechanisms that will correct most mutations. 999 out of 1,000 mutations your cells will fix. Did you know that? You have a built-in typo editor that will go in and fix most of your mutations. But every now and then one gets through. And when that happens, you end up with problems because you're now missing some instructions. For example, all dogs should have information for 4 normal legs. That's not a variable trait. All dogs should have that. But there's a mutation that occurs when the DNA is copied. A lot of times it won't be copied exactly right, and some instructions are lost. And so you end up with a dog with 4 stubby little legs because he's missing some instructions, and so his legs don't form properly. Now, if you think about it, a dog like that is not going to do so well in the wild, is he? Because he's got those short, stubby little legs. He can't run very fast. He can't catch anything. He's more likely to be caught by something else. Dogs like that's not going to do so well in the wild. But some people like dogs with short, stubby little legs because they can't jump up on you, at least not as much. And so people will take these little dogs with short, stubby little legs and take care of them and feed them and spend millions of dollars trying to keep them alive. So these dogs don't have to survive in the wild because they have a human caretaker who will take care of all of their needs and so on. That's why domestic breeds of dogs tend to be full of mutations, because we humans are preventing natural selection from weeding them out. There's all kinds of mutations in various dogs. There's a mutation that causes a dog's snout not to form properly. A dog's supposed to have a long snout, and that helps with its ability to smell and so on. But there's a mutation that causes the snout to be short. And it has a horrible underbite because the chin was designed to fit the longer snout, and the skin was designed to fit the longer snout. So it hangs off to the side if you don't clean it and get infected. And some people think that's cute, but you think the dog says, "Gee, I love having my nose stuffed into my face. That's great." Maybe not so much. Poodles have some problems. I'm not anti-poodle, but they really do have problems. And some of these are secondary results. Some of them are directly from a mutation, some are secondary. There's a mutation, for example, in a poodle that causes its hair to grow forever. A dog's hair is supposed to grow so long, and then it stops and it falls out, and that regulates the hair growth. With a poodle, that gene has been damaged, and so they can't shut off their hair growth. Their hair grows indefinitely. A poodle could not survive in the wild. Can you imagine that? Trying to drag all that hair behind it? I mean, there's no way it could survive. Poodles require human beings to give them a haircut every now and then. They need that. If you aren't careful, the hair will get in their eyes, and their eyes can get infected, and they can go blind, or get in their ears, and their ears can get infected. It can kill them under certain circumstances. They do have problems. They do have problems because they don't need to survive in the wild. They have a human caretaker who is protecting them from extinction. Otherwise, they would be gone a long time ago. Natural selection would have weeded them out. So you see, this is how we can account for the different breeds of domestic dogs. It's just the information that God built in their kind, and mutations, mistakes that have crept in and caused little problems within the dog kind. But this is not evolution, because it's in the wrong direction, isn't it? It's not evolution. Because you start with, by the way, we think the dogs that were on Noah's Ark would have been more like the wolf kind, because wolves still have a lot of what we call the heterozygous code, big A, big B, little b. So there's lots of potential for variation. The domestic breeds of dogs, you lock in the traits. It's big A, little b, and so on, which is why, domestic breeds, when they reproduce, it's almost an exact duplicate. A lot of the variation's been lost, for good or for bad. I love golden retrievers. I think they're a wonderful breed. You breed 2 golden retrievers, you get a golden retriever, and they're always sweet and pretty, just like their parents. But there's not much variation available anymore, and they have problems. Goldens tend to suffer from hip dysplasia, and they have other issues as well because of the mutations that have accumulated in their genome. That's just the way it is. And if you think about it, poodles are kind of at the bottom of the line there, because, that's kind of the end of the line. This is not this is not evolution, though, is it? Because we're not gaining new information. We've lost information, and as a result, you're losing the ability to produce variation within a kind, and so on. A friend of mine who actually has a poodle or a similar breed, he says that poodles are kind of like, if you think of it like in the world of cars, the Wolf would be sort of like the Rolls Royce. A lot of extra features on it. Windshield wipers on the headlights, that's cute. I mean, you don't really need that, but it's nice. It's a nice extra little feature. Whereas a poodle is kind of like a Kia. It's kind of, that's just kind of it. You remove one part from a Kia, it doesn't work anymore. I mean, it has nothing extra on it. So that's poodles are kind of the bottom line there. And, but this is an evolution. When I teach this to youngsters, I say you can think of the information in your DNA like jelly beans. And so the coyotes, the wild kinds of dogs, have lots of information, lots of different possibilities for variation. But as you inbreed animals, it concentrates those mutations until you're reduced down to the point where you get down to the poodle, and then you just don't have a lot of information left at that point. You have kind of the bare minimum information necessary to keep the poor thing alive. And Now, can you turn a dog into a cat by removing jelly beans? The answer is no, because a cat has different information, doesn't it? Theoretically, you could start with 2 wolves again, and by selectively breeding and capturing the right mutations and capturing the right, theoretically you could get all the way down to a poodle again. I don't know why you'd want to, but you could do that. Okay? But if you take 2 poodles and breed them, can you get back to a wolf? And the answer is no, because they don't have the instructions anymore. Those instructions are gone. So this is all good science, isn't it? Because this is stuff we can observe in the present. We can examine dogs. We can see how dogs reproduce, and we find, dogs reproduce dogs. Now you can get lots of variation within the dog kind, but they're still dogs. This is good observational science. It's testable. It's repeatable in the present. It's something we can observe today, and it's consistent with biblical creation, and it's not consistent with evolution. Evolution would require brand new information to be added to organisms so that they could constantly improve and become more complex. That's not what we see. You inbreed dogs, and they get more and more degenerate. That's just what happens. I do have to point out that mutations can be beneficial in the sense of helping an organism survive, but only by losing information. So they're still in the wrong direction to make evolution happen. I'll give you just one example of this for time's sake. There's a bacterium called H. pylori, which causes stomach ulcers. and that's unpleasant. And so you go to the doctor, and the doctor gives you an antibiotic. Nice. The antibiotic, which is harmless to you, is absorbed into the bacterium, and he's got an enzyme in him that's part of his system. Enzyme is just a protein that acts as a catalyst. And when that enzyme that's part of his system that he produces, when it interacts with the antibiotic, it converts the antibiotic into a poison, and the poison kills the bacterium, and you feel better until you get your medical bill. There's a mutated form of H. pylori. He's missing the instructions that produces that enzyme, or at least he can't produce very much of it. And so the antibiotic goes in there and it just sits there because he lacks the ability to turn it into the poison. And so he survives. But he survives because he's missing some instructions. It's just in that situation, it happens to benefit him. And so what happens then is you take your antibiotic and you feel better because you've killed all the normal bacteria. And you say, I think I'm done. I think I can stop taking my antibiotic early. Don't do that, because if you do, then the mutant form, which is resistant to the antibiotics, will reproduce, and now you've got a resistant strain, and they're harder to kill. Now, eventually the antibiotic will kill them too, because they do have a little bit of that enzyme. They just don't have very much of it. They can't produce it. And in the wild, they don't compete well with the normal healthy bacteria, because that enzyme does something. It's part of his internal chemistry. But my point is, mistakes, reduction in information can help an organism survive, but it's still the opposite of evolution. So evolutionists like to talk about beneficial mutations, and I'd say that's true, but it's irrelevant. It's irrelevant because you need new information in the genome to make evolution work. And losing information is not new information. It just happens to help an organism to survive in some instances. Dr. Lee Spettner, PhD in biophysics from Johns Hopkins University, says all point mutations that have been studied on the molecular level turn out to reduce the genetic information, not to increase it. He says not even one mutation has been observed that adds little information to the genome. Now, there are different types of mutations. There's a mutation that can cause a section of the DNA to get duplicated. People say, well, there you go, new information. I'm thinking, come on, folks, think about this. I mean, if you're reading a newspaper and a paragraph accidentally got duplicated, do you have any new information? Could you learn anything from the duplicate paragraph you couldn't learn from the original? Of course not. There's no new information there. It just makes the DNA longer, but it doesn't add new instructions. So you see, genetics really does confirm biblical creation, doesn't it? Not that we can go back in time and test creation by the scientific method, although the scientific method presupposes biblical creation, as we saw last night. But nonetheless, what we see in the present world is consistent with what we would expect, given what the Bible teaches in Genesis. Well, we've talked a lot about information. There's a whole branch of science dealing with information and its origin and how it's transmitted and so on. We all sort of intuitively know what information is. You pick up a book, it's got information in it. How would we define it? Well, we could define it this way. Information always entails these three characteristics. First of all, it entails a symbolic code system. And so when you pick up a book, and it wouldn't have to be the Bible, but the Bible works. The Bible has information in it, doesn't it? And so I see here a word, king, the word king. And I don't see a king, do I? I see a word that represents an idea. It represents the idea of a king. And so that's a symbolic code system. These letters represent something else. And so you can pick up a cookbook, and it'll mention an ingredient. It'll mention sugar. Now, you don't find sugar in the cookbook. You find a word that represents an idea. It codes for it. So that's an important aspect of information. There's always a language convention. There's grammar. There's syntax. This Bible's English. The Bible's originally written in Hebrew and Greek, some Aramaic, but there's a language convention there. There's syntax, there's grammar, there's rules of grammar, and so on. And there is meaning. There's an expected action and intended purpose. I can learn something when I read a book. The author intended me to do something. Maybe it's just to have a better knowledge of the subject, but often it's to do something physical and with a specific purpose in mind. So if you have a cookbook, the expected action is that you will combine the ingredients in the way the book specifies, and the purpose is so you won't go hungry. That makes sense. So a cookbook counts as information. The Bible counts as information. Any book you read really counts as information, doesn't it? Because it fulfills these criteria. There's a symbolic code system, there's a language, and there's meaning. There's an expected action and intended purpose on the part of the recipient. It doesn't matter if the person actually follows through on the action. It doesn't matter. All there has to be is an intended action, an intended purpose. So let's try our information detection skills using these three criteria: symbolic code system, language, meaning, and see if this is information. Could this be information? Looks like it could be. Looks like there might be a code system there. That's possible. Is there language? Oh, maybe. I mean, it looks like it's organized into possibly sentences, so it looks like there could be a language there. It's reasonable, but is there meaning in it? The only way to know that is to decode it. In fact, when hieroglyphics were first discovered, they didn't know how to interpret them until the Rosetta Stone was discovered, and then they were able to translate it. And they said, "Oh yeah, this is a legitimate language. This is legitimate information." Well, it turns out this is legitimate. This is information because I know the code. You see, I know what it means. And it turns out this is, in fact, Genesis 1 through 5 in the form of icons. You see, in the beginning, like the clipboard for a movie, in the beginning, God created the heaven and the earth was without form and void, and darkness was upon the deep, and the Spirit of God was hovering over the waters, and God said, "Let there be light," and there was light, and God saw the light, that it was good, right? Isn't that neat? So this counts as information. Now, it turns out whenever you have information, certain laws apply. Just like when you have energy, the law of conservation of energy applies, which says you can't create or destroy energy. We covered that in the previous session. Likewise, there are laws regarding information. And one of those laws is that information never originates by itself spontaneously in matter. Information doesn't just generate itself. Interesting. Dr. Werner Gett, one of the world's experts on information theory, says there is no known law of nature, no known process, and no known sequence of events which can cause information to originate by itself in matter. So information doesn't just spontaneously generate. Now, that is very intuitive, right? Because, again, if you pick up a book and it's got information in it, you probably would not think, well, that probably just happened when a typewriter exploded. You would think, no, somebody wrote that. And that comes to another law of information theory, which deals with the origin of information. And it turns out, as you would probably expect, information always originates in a mind. Dr. Gett says, when its progress along the chain of transmission events is traced backwards, every piece of information leads to a mental source, the mind of the sender. So if you pick up a book and it's got information in it, ultimately that information came from a mind. You know that. Now, that doesn't mean that particular copy was handwritten by the person, right? Because this Bible was made by a machine that makes lots of them simultaneously. But where did it get its information? From another computer, which got it from another computer, and so on. Non-mental machines can copy information, but they can't create information. Only a mind can create information. Okay, and so when you pick up a book, you know that originally it has an author. Now that's very interesting, the fact that information always originates in a mind, because what do we have in DNA? Information. The instructions to make the proteins that make you are encoded in your DNA. There are instructions for each amino acid. There's a stop codon and a start codon that tells you when to start the sequence and when to stop it and so on. DNA has instructions. It has information in it, which means that the information in your DNA ultimately came from a mind. And you see, that eliminates evolution, doesn't it? The idea that the information in your DNA gradually accumulated accidentally over millions of years, that's not possible according to the laws of information theory. I mean, you got the information in your DNA from your parents, they got it from their parents. It's been copied many times, and some has been lost because of mutations that have reduced the information in your DNA. And so we all have some problems. We all have some little health problems. I get lower back pain. I inherited that mutation from my dad. Thanks, Dad. And he got it from his dad, and so on. And so we all have our little problems that we have inherited. So we're all a little bit like a poodle, I'm afraid. Yeah. And it's only going to get worse until the Lord returns. But in any case, the fact is that DNA, having information in it, only makes sense in light of creation. It's not consistent with evolution. Science is consistent with creation. It really is. And by the way, I know that even the most ardent evolutionist, in his heart of hearts, really knows that information does not come about by chance. He knows that information originates from a mind. I know this. I did a social experiment a while back. I posted an article on my blog. I've reposted it on the Biblical Science Institute website. The article is called On the Origin of Articles by Means of Natural Selection, et cetera, et cetera. The article tries to convince you that articles do not have authors, but they, in fact, are generated as typos accumulate, you see, over millions of years. And granted, most typos make an article worse, but we throw those ones out because they're no fun to read. And so the articles that get preserved are the ones that have, useful information in them. And so articles probably started out as a single letter, and then over millions of years, that letter, accumulated other letters, and most of them made it worse. We threw those ones out. But gradually, articles have accumulated over millions and millions of years, and that's how articles come about. And there's all kinds of evidence for this, that all articles have a common ancestor. For example, the fact that many of them use the same words, right? I mean, you'd be surprised how often the word "the" occurs in articles. And that's obviously proof that they're descended from a common ancestor, isn't it? Anyway, I posted this article, and it had all the arguments that evolutionists make for evolution and genetics, just applied it to articles. And it works just as well, interestingly. And the funny thing was not so much the article. The funny thing was the comments that I got on it. Because at the time, I allowed people to post on my blog, even, and a lot of evolutionists got on there and just said, "We know you wrote this, Dr. Lisle." I said, "How do you know that? Did you see me write it?" "Oh, no. Oh, you're just taking it on faith? Oh, that's interesting. Interesting. But, well, we could check your IP address and everything and prove that you posted it. Hey, I admit to posting it. When this thing evolved on my computer, it was just too good not to share it." Right? Well, it says it was written by you. No, it says it was posted by me. And by the way, do you believe everything you read? The Bible says it's written by God. Do you believe that? Oh, interesting. Inconsistent. It was funny because I started playing the part of an evolutionist then, using all the arguments that they use and so on. And I said, you must be one of those authorists that believe that that articles have authors. And I mean, how unscientific is that? I mean, if there's an author in this article, let him show himself to me right now. And which was funny. It was kind of calling myself out. Kind of interesting. Yeah, I said, if you want to believe in authors, that's fine, but keep it in church, man. And have a look at it in your spare time. It was fun. It was a fun conversation. And you know what? Not one of them could prove that I was the author, or that the article had an author, and it would have been very easy for them to do so. All they would have had to have done was said, "We know that you or somebody wrote this article because it has information in it." And not one of them made that argument. You know why? Because then they'd lose evolution. They'd disprove evolution because DNA has information in it. Isn't that interesting? Let's talk about geology now in the remaining time. Study of rocks, how rocks form and so on. The first little myth I have to blow up is the idea that these rocks have been age dated, that we can know how old a rock is, right, by measuring radioactive elements and so on. So they call it radiometric dating. I want to show you how it works and the problems with it. It does have problems. So we're all made of atoms, these little particles that exist, and everything's made up of atoms. And so some atoms are radioactive. Radioactive means that they're, or another word would be unstable. It means that they basically will spontaneously change into a different kind of atom. For example, uranium-238 does this. That's a uranium-238 atom. Not that it looks exactly like that, but you get the idea. So it's got protons and neutrons in the nucleus. And every now and then it'll emit a combination of protons and neutrons, and that'll change the element number, or it'll emit a electron or positron, and that'll change the type of atom. So, for example, uranium-238 will spontaneously change into thorium. You don't have to do anything. It just does it all on its own. It'll just sit there for a while, and then poof, it'll spit out a helium nucleus and turn into thorium. And then thorium will sit there for a little while, and poof, it'll spit out a beta decay, and it'll change into the next element, which changes in the next one, and so on, all the way down to lead-206. Now, lead-206 is stable. So once you're lead-206, it'll stay lead-206. And the physics of this is not entirely understood, why certain elements do this. And most elements don't. Most of the stuff you're made of is stable, so you're not going to change into anything else in the next 24 hours anyway. But there are a small fraction of elements that are radioactive, and so they'll spontaneously change into other elements. Now, for any given atom, the time at which it's going to take to change is unpredictable and random. But if you have a large sample of them, you know that after a certain amount of time, half of them will have decayed away. That's what we call the half-life. And it's kind of like popcorn. You don't know which kernel is going to pop next, do you? But you do know that after 2 minutes, you're pretty well done. Right? 2 minutes in the microwave or 2.5 minutes, if they're going to pop, they've popped. Right? It's the same way with uranium-238. We can measure the rate at which they decay, and it's very slow for uranium-238. It would take 4 or 5 billion years for half of the uranium-238 to change all the way down to lead-206. And some decays are fast and some are slow, but that's the way it works with uranium. So the bottom line is if I had a chunk of solid uranium and I waited for several billion years, it would be half uranium, half lead, along with the intermediate elements, which I've not shown for simplicity. And then eventually it'll just be lead. You don't have to do anything. It does it all by itself. And lead was stable, so it'll stay lead. And so the idea is if you had a rock that has some uranium and some lead, and that rock that you pick up from the earth, you could figure out when it was all uranium. Knowing the rate at which it changes, you could extrapolate backwards and figure out when it was all uranium. Pretty clever, right? But how do you know it was all uranium to begin with? How do you know the rock wasn't made yesterday, already half uranium, half lead? And by the way, secularists do not assume that the rock was all uranium to begin with. They believe it had some lead in it to begin with. Well, how much lead should we start with? Well, you tell me how old you want the rock to be, and I'll tell you how much lead it started with. So you see, there's a problem right there. You see, there are certain assumptions that go into radiometric dating, and one of them is that you know the initial ratio of what we call parent to daughter elements. And so you can think of it like the sand going from the top chamber to the bottom chamber in an hourglass, right? So there you have uranium changing into lead. And you can use an hourglass to tell time if you make certain assumptions. If when you came into this room this morning and I had an hourglass here, and it looked like just like that, and I said, how long ago did I turn this over? So, well, that's easy, Lyle. It was a half hour ago, right? Because it's hourglass, it's halfway through, half an hour ago. I said, I gotcha. Because in fact, I turned it over just before you came in, but already a lot of the sand was in the bottom chamber. So you assumed all the sand was in the top chamber, and that's not right. It's like assuming the rock was all uranium to begin with. It wasn't. So there's assumption of initial conditions. There's the assumption of how do you know somebody didn't add sand when you weren't looking? Now, uranium is leachable in salt water. It can move in and out of rocks. Well, that's a problem, isn't it? Because the world was flooded at one point, so the uranium can move in and out. Or how do you know the throat of the bottle has always been the same size? Now, that's probably a pretty safe assumption with an hourglass, given the properties of matter. But we don't know why it is that decay rates happen at the rate they do, and they could have been different in the past. And in fact, there's very compelling evidence that they were different in the past. So these are some of the assumptions that go into radiometric dating. And there was a research project a number of years ago conducted by a group of very brilliant creation scientists. And they found that number 2, compelling evidence that number 2 is wrong. The decay rate was much faster in the past. We think during the flood year, maybe during creation week, the decay rate was much faster. And if you don't compensate for that, you're going to get ages that are way too old, age estimates that are far older than the true age. But in any case, regardless of whether you know the details of these assumptions, here's the bottom line. We know that your radiometric dating doesn't work because we've tested it on rocks whose age we know. You see, radiometric dating is supposed to tell you when the rock hardened. That sets the 0 point of the clock, because then the gases can't move, or at least gas can't move in and out. So we took, for example, rocks from Mount St. Helens. Mount St. Helens erupted in 1980, right? There have been some subsequent eruptions. And we took brand new rocks, less than 10 years old, and we sent them in and had them radiometrically dated. Now, why would you do that? It's expensive to radiometrically date a rock. Why would you date a rock you already know the age? Normally, they don't do that. Well, we wanted to test the method. We wanted to see if the answer was right, because we already know the answer. It's just a few years old. And those rocks came back with estimated ages of hundreds of thousands to millions of years on rocks that we know are just a few years old. And you say, well, that's an isolated incident. It's not. If you take a rock from Hawaii and you send it in, a brand new rock, you can take a pole, stick it in the lava, pull it out, send it in, have it dated, you'll get millions of years for a rock that you saw form. In fact, some of these methods can even give a negative age, which I think is funny. You can actually hold in your hand a rock that, according to radiometric dating, has not formed yet. So the bottom line is radiometric dating has been shown to not work on rocks of known age. Secularists assume it works on rocks of unknown age. Is that scientific? I don't think that is. What about carbon dating? Carbon dating is similar, but carbon dating is better because at least when we test carbon dating on things of known age, it tends to give the right answer. And so I have more confidence in carbon dating. Now, it's not infallible either. And sometimes it'll give a little bit of inflated ages, but it never gives millions or billions of years. With carbon dating, the way it works, most carbon is C12. So you get 6 protons and 6 neutrons in the nucleus. There's a variety of carbon called C14. There's 2 extra neutrons, and that makes it unstable. C14 will spontaneously decay into nitrogen. And that C14 is produced in the upper atmosphere as cosmic rays bombard nitrogen atoms, converting a small fraction of nitrogen into C14. And then what happens is plants will take in the carbon from the atmosphere, and they use that to build themselves. And so a small fraction of plants are C14 as well, and a lot of C12, regular carbon. And then the animals eat the plants, and then we eat the animals, or we eat the plants, either way. And so we have a little bit of C14 in us. So you're all slightly unstable. How about that? A little bit of C14 in you. And that's constantly decaying into nitrogen, but you're constantly replacing it because you're eating more food, right? You're eating more food, and you take in new carbon, and so as the C14 decays away, you replace it. And so when you're alive, the C14 to C12 ratio in you is about the same as it is in the environment until you die. When you die, you don't eat anymore, you don't breathe anymore, and so the C14 just decays away. You're not replacing it anymore. And so the idea is when you're alive, the C14 to C12 remains about constant, remains the same until you die, and then it just decays away. And so with carbon dating, you can tell how long ago something died if it was a living creature. And so, and the interesting thing is, whenever we carbon date stuff, we get ages that are within the biblical time scale, within the ballpark anyway. Very interesting. You know, we've carbon dated dinosaur remains, dinosaur fossils. If there's enough carbon left in the fossil, you can date it. And every one we've tried gives thousands of years. Every single one. Not one of them gives millions of years. If the fossils really were millions of years old, you wouldn't have any C14 in them, but there always is. You can take a chunk of coal. Coal beds are supposed to be hundreds of millions of years old, but they have C14 in them. Every sample we've tested. They used to use coal to calibrate the detection machines, because under the assumption that coal, being hundreds of millions of years old, should have zero C14 in it. But that's wrong. We now know that all coal has C14 in it. We found diamonds that has C14 in them. That limits the age to a few thousand years. There's lots of processes like that, folks. Carbon dating is not the only one. There are all kinds of physical processes that limit the age of the Earth to thousands of years, not millions or billions, or at least much, much less than the 4.5 billion. The rate at which salt accumulates in the ocean. Even fresh water has just a little bit of salt in it, which it picks up from the continents. Water dumps it into the ocean. The water evaporates and gets recycled, but the salt remains. Salt doesn't evaporate. And so the oceans are constantly getting saltier, and you do the math. 62 million years ago, the oceans would have had zero salt in them. So that's an upper limit, because you can't have less salt than no salt, right? So, and you think, well, that's a long time, but the problem is the secular age of the ocean is supposed to be 3 billion years. And that's a lot older than 62 million years. But we think the ocean probably had salt in it to begin with. And so obviously it's going to be a few thousand years old. The rate at which mud accumulates on the ocean floor, we can calculate that. There's 20 billion tons per year. Now you can get rid of a little bit of it with plate tectonics, subduction, but only 1 billion tons per year maximum that way. It takes only 12 million years to accumulate the current amount of mud on the ocean floor. And that's assuming constant rates. That's assuming there was no worldwide flood, which would dump a lot of mud very quickly. So it's consistent with the biblical age, but it's not consistent with the billions of years. Human population, how long does it take to get Earth's current population of human beings? Doesn't take millions of years. And we know that. We've been able to estimate, or at least measure, and in some cases estimate world population growth. But the bottom line is, these are all scientific estimates. You can't scientifically prove the age of something, because you can't go back in time and observe it, and science is all about observation. All age dating methods that are scientific based are based on assumptions. It's just that they tend to give the right answer anyway. They tend to give ages that are consistent with the biblical timescale. There are very few that give billions of years, and those are the ones the secularists like to use because it gives them the answer they like. But the fact is, the ages really are the evidence is very consistent with the biblical timescale. And the bottom line is, we have the birth certificate of the universe. When you ask about the age of something, you realize you're not asking a science question, you're asking a history question. And the best way to answer a history question is with a history book. And we have that in the Word of God. So the secular scientists say the Earth's billions of years old, take my word for it. God says I created in 6 days, take my word for it. That's really what it comes down to. Now the science lines up with what God says. But we know definitively because creation is part of recorded history. What about the fossils we find in these rock layers? There's evidence that they formed very quickly. Here's a fossil ichthyosaur. This is a marine reptile that once was in Earth's oceans, thought to be extinct today. And it was buried. It was killed, buried, and fossilized in the process of giving birth. You see the baby ichthyosaur being born there? They're born tail first because they're air breathers. And so as soon as they're born, they have to swim to the surface and get their first breath of air, which is kind of neat. There's a fish fossilized in the process of eating another fish. You can find all kinds of examples of this, of things that are just killed and boom, and they're just buried quickly. You see, most things, when they die, they don't fossilize. Let's do a little thought experiment here. We have our dead cat, Earl, okay? I've been picking on dogs. We'll pick on cats now. And we're going to watch him slowly fossilize over millions of years, right? Well, what happens is day 1, you have a dead cat on the grass. What happens on day 3, you have a smelly dead cat on the grass. Yeah. What happens on day 9, you have a very smelly dead cat on the grass. What happens on day 20, parts of Earl are missing. Yeah, they've been picked off by scavengers. They started to decay. Day 38, more of Earl missing. Day 65, Earl's missing. Where's Earl? He's been recycled into the environment. Most things that die are picked off by scavengers. They decay. They're recycled back into the environment, and I'm very grateful for that. If you want to form a fossil, you have to bury something. And even then, I had the wrong idea because we find fossil fish all over the earth, and I was told the fish dies, it sinks down to the bottom, it's slowly covered with sediment over millions of years because these sediments are deposited millions of years after the other one, right? No, because if this layer was deposited a million years after that layer, the top of the fish would have decayed. In order to form a fossil, you have to bury it quickly, and most fish float anyway. So if you think about it. Or they're picked off by scavengers. They don't just sit there and wait to fossilize. You've seen those Discovery Channel or National Geographic where you see the ocean floor. You don't just see billions of dead fish waiting to fossilize. It's active, right? Now, if you want to form a fossil fish, here's how you do it. You go home to your aquarium, and you dump some concrete in there, okay? And that's going to kill that poor fish. It's going to bury him quickly. And then usually there's enough bacteria left that they can eat away at the soft parts of the fish, but not the bone. And then what happens is the minerals will move in and fill in all the holes in the bone, and you get fossil. And that's how it doesn't take millions of years. We can do it quickly in a laboratory. So, and what about the types of fossils we find? You'll see all kinds of evidence for evolution, right? And I'm thinking, no, that's variation within a kind. You get different varieties of horse. Oh, but those ones, these ones are really small and those ones are big. So what? We have horses of different sizes today. These are both adult horses. They're just different breeds. Oh, but their feet were a little different. So what? It's variation within a kind. They're still horses. And by the way, they don't even teach this anymore. At least knowledgeable evolutionists don't, because the number of ribs is different. If you organize them in terms of the way their feet supposedly evolved, if you organize them in terms of the number of ribs, it would be a different order. So it's kind of interesting. This nice, neat progression. And of course, they even the patterns on there, like we don't have any knowledge of what the patterns looked like on their skin, but it's kind of interesting. Lots of different varieties of horse, and some have gone extinct. The rocks in which fossils are found, they don't take millions of years to form. Here's a set of car keys embedded inside solid rock. I don't think that happened millions of years ago. It is a solid rock. Here's a man-made clock embedded inside solid rock. That's the one rock we know exactly when it happened, right? There are all these sedimentary layers. Some of them are still loose, but some of them are hardened into rock. And there's a person down there for scale. Those did not exist before 1980. Those were formed in the Mount St. Helens eruption. Yeah. It doesn't take millions of years. That canyon did not exist before 1980. Oh, but canyons take millions of years to form. That one didn't. That formed in a matter of hours when the Mount St. Helens eruption happened. So lots more, but I'm running out of time. If I did all of these, we'd be here for millions of years. The bottom line I want to point out is that geology really does confirm biblical creation. It really does. Recent creation and a worldwide flood. And so when you see these rock layers, you need to be reminded, these are not evidence of evolution or millions of years. They're evidence of the worldwide flood. Most of these rock layers that have fossils in it, most of those were deposited during that worldwide flood. And you know what that reminds us of? It reminds us God is righteous and he judges sin. So the real message of the rocks is repent. God judges sin because he's righteous. Only a wicked judge would let sin go unpunished, right? A wicked judge would say, oh, you're guilty. Yeah, just go free. Who cares? God's righteous, and so he will judge sin, but he provides a way of escape as well. And, of course, that way of escape ultimately is Jesus Christ. Noah was able to escape the flood physically because God told him how to build the ark, and Noah's a preacher of righteousness. Come on board the ark and be saved. I'm sure he was out there preaching that message. And yet of all the billions of people, and yes, there were probably billions of people in the world at the time of the flood, if you do the math. Of all those billions of people, 8 were saved. 8. You say, oh, but the majority of people today, they don't believe in a worldwide flood. Well, the majority of people did not survive the worldwide flood. That's something to think about. And then, of course, God was the one that closed the door on that ark, which I think is interesting because God is the one who decides time of mercy is over, time of judgment begins. And so that's something for us all to remember. I'm not going to do the resource thing because we're running a little bit over, but do check us out on the web, Biblical Science Institute. And I want to thank you very much. Hope you enjoyed that.